Good morning, everybody, and welcome back. This is the last day of the course. We have 2 parallel tracks, and you chose the right track because you're in the air-conditioned room. For those in the back, I just want to give you some information. It's cooler downstairs. You can sit where you want, but it's cooler downstairs. So today is the big tech morning. So we first have Stefaan Van daele from IBM, then we hear from Google, and then actually we'll hear after the coffee break from Frank Robben, actually the big government. He's in charge of the Belgian government infrastructure for social security and e-health. But so we start with Stefaan Van daele at IBM. Will speak about security architecture. He also wrote a very interesting book about this. I have to, unfortunately, disappear because I have to give a talk somewhere else, but I'll come back after lunch, and I leave you in the good hands of Stefaan, and Barry will take over the session.
Thank you, Bert, for the intro. Good morning, everyone. I must admit, I've barely slept this night, so I'll speak a bit slower. My brain is also working slower. Give me some time to accommodate. So I'm Stefaan Van daele. I'm a CTO, but I'm what's called a field CTO. So I'm not defining the strategy of IBM. I'm working with clients all the time. So I'm at the client, and as a CTO, help the client to establish their security vision. That's my job. That's one hit. The other hit I have is I've been in architecture for, 30 years now. And the thing is, I'm now the lead architect of a large, complex transformation project at an international organization, which is in the news thanks to the President of the United States, which I cannot say much about the project because it's NATO. So it's a very interesting project, but unfortunately, I have to be silent about it. But that's my day-to-day job. I'm staying day and night at my customer, trying to get that transformation done as soon as we can. That's about me. I've written indeed the book, not me alone. It was with Mark Buckwell and Carson Horst. So that's something, if you are interested in a methodology, you won't barely find the word AI. That's a heads up. This is a methodology. That's impending of how you use technology for it. What I'm going to talk today about, if the clicker works, yes. I'll give an intro about architecture in general. I'll spend much more time on enterprise context, and that's because of a conversation I had on Tuesday evening with a CISO, and I changed my presentation totally. And so I found out that the challenge that CISOs are, so the people responsible for security in their organization, is changing so fast. And that's what is changing is the context around. Not the methodology is not changing, the context, how to do security is changing at the speed. I don't explain this. So I decide I throw away my slides and I start from scratch a little bit. I'll talk about security architecture, and I've been announced to speak about multi-cloud, but these days it's almost like I'm talking about multi-AI. Yeah? Cloud is the platform on which we deploy solutions mostly driven by AI capabilities, and vice versa. If you're talking about multiple AI solutions, you're probably touching upon multiple cloud implementations as well. Okay, what is architecture in the IT world? It's an horizontal function, as we call it. It traverses all IT specialties. So a general IT architect, I'm not talking about security, is doing the solutioning. He's designed the solution for any solution in an organization. That can be the deployment of a new ERP solution. That can be the transformation of a legacy application that has been there for 20 years around in the company. It can be moving something to cloud, moving back from cloud to on-prem. That's also happening. So it's not only towards the cloud. Some customers, for some reasons, are coming back. And so they are then deciding to do all on-prem. So that's architecture. It's a discipline. It's a profession in IBM, by the way, but it's a discipline also that you not often see. It's not that, I would say that in the spotlight, but are the people trying to make a solution work end to end, from the design, from the requirements up to deployment. And you see the different phase. So the design thinking is where you apply the methodology. There's an architecture specific on how to do architecture. That's building the solution on paper. Engineering is doing the hard work, coding, implementation, and then operation, of course, you need to run it anyhow. You or your provider have to run it. the clicker seems to be, yeah. And so why cybersecurity architecture? That's the reason. And you find somewhere the word threats. Does this pointer works? It does not, but okay, you can see it. Threats are the reason we need cybersecurity architecture. If there would be no threats, I would have an easy life, I would be retired. Then there is no more issue. And because no one is doing cybersecurity architecture for the purpose of doing cybersecurity architecture. It's just because there are multiple kind of threats to any solution you're holding in your hand, in your mobile phone, the laptop you're using, the data center you might still have, the cloud solutions you're using. All those kind of threats requires mitigating controls. And mitigating controls can be technology-driven, can be procedural, they can be automated more and more, of course. But anyhow, those controls are your countermeasures to get control over the vulnerabilities in the solution. And because if a CISO, whoever is responsible for the security in your organization, wants to spend money, you need to spend money wise. So that's the reason why you need to do what are the threats, how those threats are real from our organization. If you don't have a Windows machine, you don't care about Windows vulnerabilities in your organization, it's all running on Linux. But so there are a lot of threats, you need to see how they're applicable to me, you transfer them to risks, that's implications, what's the impact, and what's the probability, that's a risk, how big is it that the threat is becoming real for my organization, and then you need to find the countermeasures to mitigate the risk. That's why we're doing cybersecurity architecture overall. And so what are the main elements? On the top, you see the enterprise context. You're never in an island mode, whatever you're designing in a large organization. And disclaimer here, I'm from IBM. My customers are typical large organizations. So I've explained this. I do also training outside of IBM. A lot of my customers, the participants are small and medium-sized companies. They say, yeah, but Stefaan, I don't have such a team. I'm the one who's doing security in my organization. We're 50 people. So yeah, I understand that. But independent the size of the organization, you still need to have the solution. You might outsource, you have a provider doing that for you, but it does not change the necessity of doing this. Yeah? So, but in large organizations, there's typically a team, 10 people, 50 people, 300 people. The size depends on the size of the organization. Yeah? So my current customer, cybersecurity, 350 people. So the CISO is overseeing a team of 350 people, all doing a lot of things for security. That's the role of that cybersecurity team. And so that's the context. And architecture comes once you know the requirements. And that's, funny enough, a challenge. Christian will probably testify as well. Some customers cannot define the requirements properly. I've been in cases where I walk in and I write requirements for them. I say, what do you need? Yeah, I need a secure solution. That's a good requirement. Let's make that more granular, more specific. So requirement seems to be sometimes hard. Maybe now, thanks to ChatGPT and the others, less. They also give me my requirements because I don't know them. That's literally what's sometimes happening. But anyhow, requirements where it all starts. And requirements are driven by the enterprise context. I'll explain that later. You need to do the architecture, and once it's built and done and tested, it goes in operations. Yeah? And then you get the assurance part, testing, quality assurance, and governance. Governance is about the how. It's that I'm doing all those steps. I need to define a governance model. Someone needs to define the approach for the company. So for the next maybe 30 minutes, I'll talk about the enterprise context because more and more challenging and changing at a fast speed. Sorry for the clicker speedness. Yes. So the first thing is a CISO has a budget, and that budget he needs to define every year over 2 years. And I did this exercise. This, by the way, conceptual. I discussed it with the CISO some 5 years ago now. So we sit together. I had helped that person to define the strategy and the budget for the next 3 years. And so you have to read this like on the bottom, things you know which can be planned almost years up front. I have, as a CISO, a running infrastructure. I'm using a security monitoring tool. I got an endpoint detection response tool. I've got things that are going on. That's the bottom layer. I've got already technology that I'm using that I need to maintain. Pay licenses, maintain it, keep it up and running. Predictable, very predictable. Yeah, so that's the next thing is compliance to regulations. It's all in the news every time. There is DORA, there is NIS2, there is CRA. All organizations have a lot of challenges to comply with new regulations. I heard yesterday, like, they said there's sometimes more faster regulations than there are new versions of a product. That seems to be true, but anyhow, as an organization, need to comply to a set of regulations. Does that bring security? Yes, to a certain level, but that's not enough. Then starts what you really want to do is mitigating risk. Remember, that's like why we're doing cybersecurity, because we want to do risk mitigations. And that becomes like less predictable, but so you have as a CISO to say like, okay, which are the highest risks? Every year, the threat landscape, of every year, not every week almost now, the threat landscape is changing. Yes, question? Yeah. Well, that depends when that have to be done. So the thing is, was it predictable? Then it should have been in the budget. And so like regulations typically are announced within, you have to be compliant by a due date. That should never be a surprise that you have to comply with the regulation. It might be, that's another choice, that you decide not to comply. That's a risk that you can take. Yeah, but I've heard CISOs saying that to me. Say, I decide not to comply because I don't have the budget. Yeah. Yes. Mm-hmm. It's almost a CIO discussion, less a CISO discussion, I think. But it's because, okay, I don't know the answer to your question, honestly. You could think like, do we have to replace that with something that we don't have yet and we take it from a cloud, or we go leasing things? It's more a financial discussion and predictability. Honestly, that's why it's the second layer. The thing is, regulations are still planned, yeah? I get most of the customers or organizations I'm talking to have more already the next layer, because business, they change their mind. Business is where you come the requirements from. So these business specific things, they say like, yes, but we've seen this solution and our competition is going that way. And so halfway your year, you made your budget and they come with a total new thing. And as a CISO, I need to secure that, because making business is taking risks. And as a CISO, you try to secure it, mitigate risks, but you don't sign off the risk. The sign off of risk is taken by the business. The CISO never signs off for a risk. The CISO identifies them, say like, if you want to mitigate what I call an acceptable level, that's the budget. And if we say, no, that's way too high, but that's even more than we want to spend on security, then the CISO say like, sign off the risk. I've seen CISOs with a pile of risk letters on their desk, signed off by the business. The business said like, we will take the risk, we will go, we don't want to wait security to follow. So, honestly, I think regulations, even if they replace your technology, that's something you can plan for. It's not coming the next month. No, normally not. Regulations coming years in advance, you see it coming. GDPR, how long was the storm? Yeah. So now we get the AI regulation. There always a time frame. You get NIS2. It's a lot of things. NIS2 is driving a lot of changes in organization, because are they essential or not? That the kind of discussions. Well, yeah, it's fine. Okay. On the top, as I said, it's a higher priority, but it's less predictable. And the worst case is the black swan. what we call the unpredictable event. So you cannot budget it really, because every organization might, a ransomware attack is a black swan. So it's something you don't budget for, but it has the highest priority, and it's not planned, and so you need to cope in budget. That's just to say, any CISO has a limited budget to do security in his organization. That's the challenge, and you have to work with it. And security architecture, especially for me, is driven by security policies. I'm not defining as an architect the policies. And there is an example, ISO 27002, it says like, the policy requirements, again, requirements comes from the business, the regulations, and risk and threats. And I'm a lazy architect. I don't start working before someone put the policies on paper. So I say like my input for security architects are enterprise security policies. That might result, I have to write them anyhow if they are not defined yet, but most large organizations have a nice set of enterprise security policies. If you go on, this is the CISO office, and the CISO office is 1 or 350 people, and you see like the 3 things, the business needs, the threats that are coming, the regulations impacting, and that are, of course, I'm working in a specific industry, there are specific industry, financial has specific standards, the pharmaceutical have specific standards, or standards specific to an industry, and then what I said on the bottom, he has, and so or she has a limited budget. Yeah, that's the constraint that CISO have to work. That's the input. What is the output? You need to set up a security governance, to do risk management, compliance, as I said, audit and testing of security, educate users. Yes, they still click on that link to win an iPhone. They still today. So you have to continue user education. You have to run operations. You have to need an emergency response team, if it's a virtual one. In small organization, it's a virtual team. Larger, you have a dedicated team. Something happens in the organization. People need to react on that from a security point of view. That's the emergency response team. If you're lucky, you get an engineering team. And as a CISO, you have the fun to join all these boards and committees where you have to ask for money, you don't get it, they need to go back to the drawing table, you have to go back, and so on. So if you're higher in the organization, you might be part of the board. If you're not, then you're asked once a year to explain how you get out of the news, because that's the life of a CISO. He's invisible when he's successful, and he's on the front page when he fails. That's how a CISO is, that's the life. And I'm not a CISO, I'm an architect supporting CISOs, but I've seen it. It's always not the nice position if your company got hacked and got on the newspapers. So all this to say, where is now security architecture? And that's just 1, 2, 3. Security architecture is 3 levels. If you have a large organization, as part of your governance, you define something we call enterprise security architecture. That's not technology. Just say like, in my organization, this is how we're gonna do security. These are the standards, this is the approach, these are the policy we want them to use, these are the patterns they should use. And then where the security architecture is really happening is this 2 is what any solution team does. If it's now a small DevOps team, or it's a large team, if they're using Agile or Waterfall, I don't care what the methodology is. I do care that they do the solution right from a security point of view. Yeah? And so you provide them the principles. What's the outcome? A principle is not a design. A principle say like, that's the expected outcome of your design from a security point of view. And that's how we're going to test it. So you have to do the validation. If they introduce a new solution in your organization, and I'll explain that later on, there are a lot of things they need to take care of. And that's where you, as a security responsible entity, say like, okay, we can approve this. This can go live, as we say in IT. It goes live. And the third one is the fun part, but it's only in the CISO team, that's deploying security solutions. That's also security architecture, but for very specific security solutions. Deploying a security monitoring solution, deploying a privileged access solution. Very small team typically, but that's also security architecture for security solutions. So keep that in mind, that's typically how it goes. A lot of requirements, a lot of things to do, and security architecture has a role there. A limited role, but yet. So if I put that in a larger picture, and bear with me, I'll make this complicated, but I'll try to do it slowly before we go to the sophistication layer. This is a very simple drawing of an organization. I didn't find a name, so I put XYZ. I could have been Acme. In that team, it's not proportional. I put the CISO team. That's out of proportion to the rest of the company, but that's, I want to say. And there are 4 large blocks I identify: governance, risk and compliance, your strategy, building security solutions, and doing security operations. Yeah, that's what I say, 4 elements of a security organization. On the left side, still my context, external to my organization, regulations. Unless I'm government, I don't define regulations. The external threats, the best practices I should use and look after, standards and so on. ISO, I mentioned ISO, there are many more. And then, luckily, there's not only external threats, there's also a lot of source of what we call threat intelligence, open source threat intelligence, paid services. We can get a lot of information from outside sources as well that support us to cope with the threats. On the right side, the business, whatever my business is of my organization, there is where the real action happens. And typically, a lot of projects are going on, IT-specific ones, they still are necessary, but mostly business-specific organization. That runs on a technology landscape, totally outsourced, running in the cloud, all in data centers. Welcome to my life. So that's the still reality for large organizations as well. Sometimes a lot of legacy in data centers, and I need a team to run that infrastructure. So that's a simple version. That's a bit more sophisticated version. And let's take some time to walk through this. So operations start on the bottom. You see there are a lot of things, and I'm not even complete here. So there are, I put some references when you find more details about this. There's what's called a CISO mind map. You get even a triple number of activities in security operations, but that team has a lot of things to do. They have to do vulnerability scanning, find vulnerabilities and fix them. I put scanning, but I should have put management, because detect them is just the easy part. Fixing them seems to be the hard part. Configuration, we call it compliance to a hardening standard. For example, CS benchmark level 1, level 2 is the way you harden the system. That means I secure the configuration of a system before it gets deployed, and I know I don't enable FTP or Telnet on that system, so I don't create open doors. A system out of the box has so many open doors. Hardening tries to close all the doors, and that's a secure configuration. Thanks to cloud, that life became much easier than on-premise situations, but still, it's not because in cloud, it's happening in the best way. Identity and access management, that's where my security journey started 26 years ago, so that's still a challenge today. Still interesting discussions, even yesterday, on identity and access management. So it's, I would say, but I'm biased, the most important security aspect. So it's with right identity and access management, much less troubles in operations. That's just my view. A lot of people are focusing on security monitoring. Yes, that's important, but it says what it is. It's monitoring. It's post factum. Yeah. So it detects what happened. It does not prevent. In security, the best controls you can implement is the one that stops things from happening. That are the ones you're looking for. Those are the most expensive ones. The cheaper ones are the detecting. They don't stop anything, but detect, hey, something is broken. Yes, good to know. But what could we prevent it? So security is always that. You have what we call preventive controls, detective controls. Preventive are harder to do, they're mostly expensive, and business don't like them. If you stop an application with a web application firewall, say, yeah, it's not secure, and business say, yeah, but that's our customer portal, it needs to work. Yes, that's the balance. So preventive controls always hard to do. Strategy, as I said, I showed how you come to a budget, but that's not one thing. It drives also how you set the governance, and then you see enterprise security architecture, ESA, there as well. On the right side, I said business projects, and then you run your infrastructure on cloud, on-premise, mobile devices, operational technology, software as a service, you name it. It's all part of your landscape, and you need to secure most of that, what's in the realm under the control of your organization. Of course, you say like, yeah, but how do I manage the security of my customer devices? You don't, but if you're a bank, there are some ways you can do it. All your online banking has some security measures to find out they're running on a jailbreak in the phone, iPhone or Android phone. So they still do something on your device. They don't change the configuration, but they try to detect in which kind of context is that mobile app running. So that's you need to find security solutions for the different type of IT components. Sorry, that clicker, no, that's where I want. So again, the 1, 2, 3, business requirements, top right, regulations, top left, threats, 3. And so that's the, you'll find back enterprise security architecture, solution architecture for projects, and then our own security engineering. Now, what has changed? This. Oops, and that now the clicker works too fast. There is AI everywhere. I'm not telling anything new. This is day to day. It's part of all our life. And there is the good, the bad, and the ugly, as you can see. The good one is there is AI to make my security job easier. All the security vendors making use of AI to improve how they detect anomalies. They're using AI to help you to define policies. You get a lot of AI capabilities improving how you could do security. That's the good. The bad one is the whole organization is using AI, and you don't even know about it. So some of them you know because they tell you how we're going to use whatever ChatGPT, we're going to use an LLM, we're going to build an LLM. That's when your hair goes up. Then in the business say like we're going to build our own LLM. That happens as well. So that's the bad news. And the ugly news is, yeah, you're not the only one, of course. All the adversaries, even now inside or outside organization, are also making use of AI. So that's the reality. So you have to look like how, as a security organization, are we going to secure the use of AI in my organization? How am I going to use AI to make my security better, what I'm doing for security? And how can I cope with what's happening on outside making use of AI? And that's the real life of a CISO today, of any person responsible for protecting, improving the security of the organization. And so that's the reality of the enterprise context where today people have to deploy solutions. How are we doing from time? I'm still have 30 minutes to wait. So let's talk about security architecture itself. It's written in the book. I'm using a bit of different diagram than I used before, but it's, as I said, it all starts with requirements. And a lot of security requirements are not defined or they are implicit. So they say like a derived requirement, we call like you need to encrypt the data at rest. I store data away on my bank, I need to encrypt the data. It's stored encrypted. That means I need a solution to encrypt data, decrypt the data, I need to manage the keys, so I need a key lifecycle management solution. That's not a requirement. They don't say implement the key lifecycle management solution. No, they said encrypt the data. So that's what we call a derived requirement. So the security is always looking like what are the real needs and what does it mean from a security point of view. You need to do your analysis, like what are the requirements from compliance, what are the threats applicable, what are the best practices, and then I make what I call a logical design. Conceptually, building blocks, very technology agnostic. I don't go for a specific technology at this point and just say like, what do I need? I need maybe a reverse proxy to protect the web application. Maybe I need an OAuth authentication capability because that's how it will do the authentication over a REST API. Whatever, I need to look like building blocks. And when I've got my building blocks, I'm doing what they call the technical design. Then I introduce technology. It will run on Google Cloud, it will run on Azure. We need to see like, what are the capabilities out of the box? Do we have something to add on it? So are we using only cloud available solutions? Are we bringing third-party solutions to the cloud? And so on. Once we made our technical design, that's the fun part, we break it. That's threat modeling. We break it on paper, not yet in real life, but that's later on. The first thing you do as security architect is try to break the solution. Where are the holes? What does not work? How can I get in? How could I get access to the data? Because threat modeling is the art of finding the vulnerabilities in the design. Still, it's on paper. Well, no more on paper, but it's somewhere defined. And so with threat modeling, they try to find what are the weaknesses and how can we improve within the budget. Don't forget, also a project has a budget. So you might decide to go back to your drawing table and figure out how to do things differently. Once that passed, it's iterative. It can move back to the arrows goes only forwards. That's the best case. In reality, of course, you might have some loops in this at any moment. Then you do design for operations. Are we going to run this ourselves? Is it a third party going it for us? What is done by the cloud provider? What do we still need to do ourselves? I'll come back to that later. And then once you've defined it, you need to find a test plan. A test is the necessity. You have to do tests. And security, you're really think like pen tests, red team tests, scanning of software code. If you would have software code, and you say like, yes, I got a pipeline, what we call a CI/CD pipeline. I got quality gates. One of my quality gates scanning the source code, too many vulnerabilities or too many defects, back to the developer. And that be automated these days, but anyhow, that's how it is. You still need to do a test, and once it passed all the tests you've defined at the beginning, because you get your compliance and your risk controls, you mitigate the controls, so that's be tested, and then you say, look, it this passed the test, now it can be deployed, and then it goes to run to what we call handover to operations. In the early days, I can say that because I started in this job 26 years ago, this was almost all manually. These days, this can be almost end-to-end automated, almost end-to-end. I would say not completely, but almost, thanks to AI. Even before the age of AI, there was a Dutch bank doing that testing and deployment fully automated. That means they created a sandbox environment, they deployed everything on a sandbox environment, they do all the tests they could, and it passed all the tests, which you always find issues, but if like severity, it's in level 1, 2, 3, 4 defect. If you get like no level 1 and not too many level 2s, you can decide we'll deploy this solution. And that happened automatically without a human intervening. So the whole test cycle and deployment, you can do the automation of what we call the quality gates. That was even before AI was around the corner. Something on design and architect decisions, my favorite topic, and I'm not the only one, because this comes back in every book you will read. Yes, sorry? Sure. Yes? Yeah, that's a risk, but you have different type of tests. The developer team, they do only what they call functional test. They build a solution and they test, does it what we've built it for? Functional test. Security, I don't care about functional that much. I care about, is it secure? And so you got these pen testing tools, and it's a web-based application that tries to do a lot of, let's say, even SQL injection. I don't know why it is, but it's still there in the OWASP top 10. It was there 26 years ago. It's still there today. It's like no more on the top 3. I think it's I don't know where SQL injection is today, but it's still there in OWASP. So those tools test those kind of vulnerabilities. They try to figure out, and yet I say like we call like black box testing. I don't know the code. I do them from the outside to try to break it. You got this, it's called this, I forgot the name, sorry, that you've like, you don't have the code, but you can see what's the effect on the system. So you see like, oh, the CPU is increasing, CPU utilization is increasing. So you get some view on what's the result of your tests, and that's no longer black box. I think it's called glass box, something like that. So the idea is, I don't know what the source code is, but I can see the implication. I see my disk I/O increasing, I see the CPU utilization go, memory usage, and so on. So you see the side effects of your pen tests, and of course, when you develop the code, then you can start your source code scanning, but it's even before deployment. Those tools, and that's now what Mythos and the other frontier models are so good in, finding vulnerabilities in code because they build context to it. So the previous source code scanners looked at grammatical anomalies, I would say, mistakes, buffer overflows. The frontier models brings to the next level because they build context, they build a state, what that application should do, and they find much more vulnerabilities because they know the context of the code. They build them because they build them themselves on the fly. Did I answer your question? Yeah. So, but sandbox, I mean, is there a risk that you would oversee? I don't think you're biasing that how you test. It might be more in the functional part, but even in functional tests, you always try to find the use cases and the abuse cases. You should always try to do tests of both, of course. Yeah? Use cases are the functional test. Abuse cases are, let's try to break it and see what it is, what it does. Yeah? Okay, architect decisions. This is not publicity for the book I've written, but just to say, like, in architecture or in any design exercise, if you don't have time, you're in a rush, the only thing you have to put on paper are architect decisions. Yeah, and that's not me saying that. You can start reading that in all the other books as well. The one from Gregor Hope, people like to read a very good one. The software architect elevator, and why the elevator is like, well, an architect needs to go to the engineering room in the basement, talk to the engineers how to implement a solution, but they have to go to the penthouse as well through the elevator and explain the sea level. Why does it not work? We promised 2 months ago it would work, or we would not be hacked, and so on. So an architect has to write the elevator of the organization. It needs to be the translation between business requirements, what sea level is expecting, towards the engineers implementing. Yeah? That's the metaphor that Gregor Hope is using in the software architect elevator. There's another book on doing design and architecture in Agile, because Agile, why we doing the architecture? We're doing Agile, next sprint, we change our requirements and we go on. And so they explain nicely in this book why you need still architecture, even in Agile, even if you get sprints of 3 weeks, even you're using vibe coding, whatever. So that's the very good book on that, how to do architecture. And they say architecture is a flow of decision. I really like that term. And so that's what it is. At the end, it's a flow of decisions. We, in our book, quote Grady Booch, and he say like, architecture represents a set of significant design decisions. And what's significant? Significant is where the cost implication is, where you have an impact on the solution itself. Funny enough, I was reading not a while ago the dynamic workflows, a new capability in cloud. So it's like agent-based software development. It's like not 2 agents, it's like hundreds of agents. Some are building code, others try to break the solution. And the guy who has written it, the link is in my presentation, said like, it becomes even more important to have architect decision records. Yeah? So even in these modern times, architect decision records is what makes a design or an architecture successful for different reasons than in the current context than it was 6 years ago, but still very relevant. This is a last-minute drawing. Sorry for the low quality. You see, I don't use AI to generate my slides. I'm that old. I still create my own slides. I don't prompt them. But what I want to say is, it's based on discussion also of last Tuesday. There's a strange thing going up on how people looking, and I'm talking about CIOs, not the CIOs, looking at the applications used in-house. In the old days, you typically have some home-built legacy solutions, a very company-specific solution, running on a bank, we can say it, running on COBOL on mainframe, but take other, even in the healthcare, they have somewhere running very specific applications built over years. And so it's a lot of effort, and it's so written to the business, it's perfect from a functional point of view. Yeah. Of course, you have also what we call commercial off-the-shelf solutions, whatever you're using as what you buy. You could take them on-prem if you're still old-fashioned, or you take them as a software as a solution, of course. Then we start all doing vibe coding. We're prompting like, hey, write me a function that does this. That's all behind us as well in the meantime. Now we get like the cloud work, or in IBM I have to say we use Bob. Yeah? That's our automation. If you don't know about Bob, you can Google it, you can try it as well. That's automated software development. I'm just prompting, I say like, go for design mode, and then he puts himself in as the architect and say like, I want a solution to this, and he starts making your design, and he asks like, is that what you want? And then say yes, then he goes to build mode. Then it's build a solution for you, whatever language you choose, and then you go to test mode. So these things are what we called SDLC, software development lifecycle, using AI agents. And we're not far away, I think, that we can do it autonomously, that AI will do it end-to-end for you. Yeah? So that's the... and those two last facts make that CIOs, not CISOs, CIOs are considering, hey, that legacy solution, why we don't rebuild this? Why do not say to our AI, here's a source code, my developers who wrote this are almost retired, maybe one still is leaving, almost. Can you not write this? So there are some CIOs of large organizations thinking like, let's rewrite the code. And so that's an interesting thing, because remember when I sit on security, there might be risks related to that. But it's maybe from a business point of view, a very good idea. There was a bank in Belgium called it the pension wall. They were hitting the pension wall because all the COBOL developers were retiring in the next 8 years, I think it was. So they say like, yes, within 8 years we no longer understand our core banking applications because they're all retired, laying on the beach. So who will maintain my COBOL code on the mainframe? And so when I talk to those people, I hear that there is a shift in ideas on how to cope with that legacy. And so it might be that we replace them by current code, but from a security point of view, that's where I step in then. I say like, okay, but what are the risks making that decision? So, and because the risk is a bit here, the risk is your CI/CD pipeline. I'm not going to explain everything here, but CI/CD pipelines have been around the corner for a while. They're getting more and more automated. A lot of things are happening. You make your design, you have your development environment. So which solution will you use to write code? Is it Visual Studio? Are you using something else? What are your libraries you're going to use? And especially that's where the concerns is, because that's also where the risk is. A lot of risks today are not your developers using a prompt to write code. It's more like what's the third-party libraries that they're using. And so we call it supply chain risk of third-party risk management. You might be vulnerable by the backdoor. People using libraries automatically, when they deploy a solution, libraries get downloaded. They're part of code that have been written. You don't even sometimes know which libraries they're using. There are famous example of NPM. Well, how long was it infected, NPM? I think 2 hours. And it had in 2 hours over thousands downloads. That means thousands of applications possibly were vulnerable because of an infected library downloaded by pipelines. So going back to the idea of the business or the IT say like we're going to rewrite legacy code, great, but shouldn't we first how can we secure our pipeline? Because developing code is nice, and it's even more nice if you can do in days instead of months, because it's the reality as well. Now writing code, there's an experiment of the guy on using the dynamic workflows from cloud. He has written a code, 750,000 lines of code in 7 days. 7 days. That would otherwise take him months and months. So that's the reality. And so the fact that AI does accelerate, there is more and more the the feeling that that is doable, that it becomes like a good idea. But from a security point of view, I would say yes. But should we first like try to harden as much as we can all the things we do to software development and ensure we don't get infected by the backdoors. There are some famous examples of SolarWinds. Their SDLC got infected, and they were not after SolarWinds. That company was after where SolarWinds was used. For example, Microsoft and others, because they deployed their malware as a module as part of SolarWinds. And SolarWinds, if you don't know it, it's a monitoring tool. So we have agents everywhere. That malware had access to anything in those systems using SolarWinds. And that was a supply chain attack. That was companies deploying a malware code as part of your software development pipeline. So you get part of the whole code, even signed with the certificates. So they were really part of the SDLC. And so it was stayed invisible till that security company, I don't know who it was again, was it CrowdStrike, who figured it out? There was something wrong with SolarWinds. And it's not bassline, but bassline. Sorry for the typo. It's not music today. Okay, that's the regular SSE, and we have DevSecOps. DevSecOps is how to bring security in a DevOps solution. And that changed also to AI. And so now AI, what's the most important part is the the data, because everyone say that, even if you take an existing model or you want to build your own model, if you're that adventurous. But the data is a part, so there is a data pipeline as well. I need to think like how I'm going to secure the data end to end, because if I don't have security of my data, if there's like a bias in the data, someone's manipulating the data, I might impacting the outcome. And if you build your own model, if you're into that, then you think like, how do I get my model development secure end to end? So when you bring this all together, you have not only DevSecOps at the bottom, but you think like, how do I going to do this? My DataSecOps, how do I secure the lifecycle of data that I'm using in my models? And if I deploy design and deploy my own models, how do I secure that lifecycle of a model creation? And so it's no longer, and today I would have an AI SecOps. If you go further, like it seems like AI development, but an AI behind the scenes is an LLM, maybe a small one, but it's an LLM. You have to see like all those different things that are in your organization, because people like to build these days much more than they were before. They were doing before because of these capabilities brought by AI solutions. I see much more eagerness to start building things themselves, but you have to think about how we're going to do it in a secure way. Because if you don't do that, you might end up with something that's built, looks very nice, but maybe so vulnerable, or even containing malware without you knowing it. So to wrap up for today, I'll talk a bit about multi-cloud. As I said, or it's more multi-AI. Multi-cloud, and I'm giving just 2 examples, there is always a shared responsibility. And shared is always interesting, because that means if it goes wrong, you look at each other, so like, whose fault is it? The other one, yes. And especially, I like always like this shared, even where it say like, it depends. That's Google, I must say, they are straightforward. It's either us, it's either you. Microsoft leaves something in the middle, say like, depending which model, it might be us, it might be you, let's discuss. At the end, identity and data are always with you. Whatever model you choose, you decide which data goes there. They don't decide, the cloud provider. You decide which data you put in the cloud, and you decide which user should have access. That's your decision. The technology, that might be the cloud provider, but what you put there from data, which user can access, that's totally your decision. The same exists, of course, now with AI. Sorry, I could only find the Microsoft one, but you see also here, like, depending if you look like Copilot or you build your own model, and on the left side, you get again a shared responsibility. So it's not because you're running your AI in the cloud that you're no longer responsible for what you're doing, and no surprise, on the top you will see the data and the identity is still with you. So that's the most, even using Copilot, it's still a lot of your responsibility which data Copilot gets access to. So that shared responsibility is a bit different, but it's not a way because of the fact you're using AI in your organization. Some of the challenges, multi-cloud, there are a lot of challenges. There is, from a security point of view, it's like, what do I do within the cloud and what do I do across the cloud? Security monitoring is one of those. How do I keep, from a security point of view, a view over all the different clouds happening in the different cloud instances I'm using? I know a large bank in the UK, purposely, they're using the 3 that mentioned here, AWS, Azure, and Google Cloud, because they say these applications, this type runs on this cloud provider, this runs on this. So they purposely, intentionally decide to run different type of applications at different cloud providers. That's not for all type of organizations. Some organizations say like, I need to build up skills, so I stay with one cloud provider. It's already enough to learn about one cloud. How do I cope with technology knowledge about 3 cloud providers? So it depends. If you're in that situation, and I don't mention here hybrid cloud on-prem with any of the cloud combinations, 2 or more. So that's the idea. So hybrid multi-cloud, how do I monitor this? That means I need to detect anomalies going on in all the 3. So I might have security monitoring solutions provided by the cloud provider themselves, or I deploy something on top of the 3. And that's one of the decisions typically when you have multi-cloud situations. From a security I'm always in favor to use the cloud provider capabilities because they can do it best. But there are some things you need to decide. What do you do locally? What do you do across the different cloud providers? Gartner has defined what they call the cyber mesh architecture, CSMA. Yes, question? Yeah. Data portability. Mm-hmm. I'm a consultant, so the answer is it depends. And the reality is also, there is honestly, that's not even related to cloud. Because if I would go from one database to another database, I got exactly the same issue because I got a database, Oracle, and I want to move it to Microsoft SQL Server. I got exactly the same issue. Even I want to maintain the database schema and so on. So you still need to find a way how to do this. You get what we call this virtualization layer of data warehouses on top that are using these connectors to different backends. So they can say like, because they even do the security layer on top of that. So they make your whole data layer as one large warehouse. And so that might facilitate that one. So if you don't implement that layer on top of all the different data repositories you have, because data can be in so many different repositories, I got not the general name, but it has a name, but I would call it like a data lake or a data warehouse. But it's like a virtual layer on top of the technology behind it. That would facilitate, hopefully, your moving of data. And because it's, at the end, reading the data is not hard. But it's because you do that with the applications. It's like how moving it and giving the exact same access control implement to the same data. That's where the tough part starts, of course. Imagine that they have used what we call in databases row-level security to access, because in database, you can say at each row, I can apply security access control. That's called row-level security. The most secure way to access, it's not about it's access control per row. Imagine if that's so technology specific, that's not easy to transport it to another database. So I really would say like, it depends how mature they are in organizing their data at enterprise level, and did they go for that virtualization layer that might facilitate that. Because it's not only data. If you would say, I need to move virtual machines, which sounds like easy to move a virtual machine, I can tell you that's not always that shift, what you call the lift and shift. That seems to be sometimes harder to do. So yes, good question. I would say it depends where they are. If they are like stovepipes, vertical organized, I think it's a lot of work. If like they have this data virtualization layer, hopefully it should be like in knip. Don't know if that's true. Okay, I'll move on for the sake of time. LLMs, AIs have their own vulnerabilities, only showing the OWASP top 10. There are a lot of things you can say about AI, and security architecture can only do a little about it. I'm not, because I see like misinformation. If you compare AI with dynamite, the abuse case of dynamite is clear. Nobel invented to make mine safes, and the army thought like interesting invention, let's use that in war. But AI, the capability to abuse it, AI, you are faced with day to day almost. So there's so many abuse cases with AI, and just like misinformation, not much you can do as a security architecture point of view against misinformation. But of course, you need to protect your organization if that's a data ingestion part. How do we cope with that? What you hear in the news or what you see on the internet, like people are saying, not you can believe anything anymore. What you see on digital, that is probably more and more true. Nothing that you can fix with the security architecture solution. So excessive agency is something that I want to elaborate a little bit. If the clicker is really thanks you. Because what's it? what is happening now? And it's, I don't know, Anthropic, if they even asked Trump to do this, but again, Anthropic has this mythos, and then fable coming after. What's the consequence of those kind of frontier models? That's the time to exploit. There is a vulnerability detected. Look, in 2018, took 2 years, more than 2 years to find an exploit. Now it's 8 hours within the day. There's an exploit for a vulnerability. That is a changing thing. And you can say, like, this is not hype and marketing. Well, the reality is, of course, that the adversaries are not waiting till that's perfect. They're already doing this for now. So the fact that there is this is shortening all the time has an impact. And I refer to this one. This comes from the Cloud Security Alliance, and I could put like a frontier model ready. This is Mythos, now Dash, Microsoft Dash, and I presume there are others as well. So they say, how do we even prepare for this? Because some CISOs I'm talking to, they call it the vulnerability storm. I think 2 weeks ago, Google Chrome, 300 vulnerabilities published in one day. Not the problem of Google, but it's like there are so much vulnerabilities found. Microsoft is in much more. So much vulnerabilities found. They say like, it's the patching. We need to patch all those vulnerabilities. If I get like an organization with 20,000 workstations, that means I need to fix vulnerabilities on 20,000 workstations. That's the reality. If I don't do it, any of those individual workstations might be vulnerable to an attack. And so the vulnerability storm is coming, or is already there. So that means your operations to patch them are becoming suddenly much more important. The other thing is reducing your attack surface, because they say like, okay, I need to close all the doors because that's where the things will get in. The adversaries will try to use. So on my conversation on Tuesday evening, it said like, we're looking how much can we reduce now the attack surface, because that's really where the challenge is, of course. Don't forget, I said in the beginning, there's still insider threat, but hopefully that's a risk, but maybe not so large as outside external threats. But you need to do something like, how can we reduce the attack surface? As I said in the beginning, strategy, risk models, they throw the risk model out of the door. It's changing completely. You have to rethink how to manage risk, because the fact how fast it's going. I got my brother-in-law is a senior developer doing development for 40 years. He said, my life of developer has changed in the last 5 months, much more in the past 40 years. Say how we have to write code and how we need to secure it is totally changed now. It's and that speed of change for large organizations which are slower in adapting to change. It's especially when to change the humans. Deploying an agent on workstations, easy to do, I can tell you. Changing 20,000 people's behavior is very hard to do. There is no agent for that yet. We will get there when the chip is in our brain, then we can easily change the behavior, hopefully, but not now. And so, I don't go into all the points, but you understand that the fact that the threat landscape is going so fast, the fact that the exploits are there much faster than you were hoping for, because in the easy days it was like, yes, the Microsoft patch Tuesday, we get the patch on Wednesday, all the patches are published. Yeah, you don't have weeks anymore. Sorry for that. That's the reality. This clicker has its last days, or I'm not. And so there's a paper. What are we going to do about it? And everyone is using agents. So what we're going to do with is Anthropic published a paper, Zero Trust in Agentic AI. Again, because no one is doing AI without agentic AI, apparently. That's my observation. I might be wrong, but I see agents used everywhere for the good and the bad purpose for both. And MCP servers like popping up, like, how you say that, champignons, mushrooms everywhere. So it's linked like there is an ocean of MCP servers providing capabilities to agents that make use of it. So that's a lot of things, interesting things, but from security, sometimes it gives me the gray hair. And so that paper, I like it because Zero Trust is an old thing that's invented 2011. If people were old enough, they know the Aurora attack of China to Google. That was when Zero Trust had started. The Brand Corp ID started after Google being hacked by the Chinese government on spying on the opponents of the regime. And so Google said, we're going to change the total way. They didn't call it zero trust. That was done later by Forrester, but that's where it started. And today, zero trust even is equally important in the agentic AI. And that was my last slide. Thank you. That was a quick overview for security architecture.